Alright, ladies and gentlemen, we are ready to start lesson 2.4, which is on vertical angles and linear pairs. So yesterday we looked at these special relationships of angles between complementary and supplementary. Today we're going to take a look at special relationships between vertical angles and what we call linear pairs. So once again, our goal is to find angle measurements, but we're going to be looking at what happens when we have lines intersect, these special pairs of angles that we create. Alright, so let's get our vocabulary. Vertical angles. Two angles are vertical angles if they are not adjacent, which means they cannot have a common side. So we're going back to pulling on that vocabulary from yesterday. And their sides are formed by two intersecting lines. So we take a look at this. We have to have two intersecting lines. That's the part of this definition that I look at. So we have to have two intersecting lines. Put your arrows on to get your intersecting lines. And we need to have angles that do not share a common side. So if I put a 1 here, and let's put an A, I'm going to use letters. If I put angle A there, it shares a side with angle B because they share this side. If I put a letter C here, if we notice A and C don't share any sides. So we would say A and C are vertical angles. Well, if I keep going around and numbering, we've got D. And once again, D is over here. And D and B do not share any sides. So we would say D and B are also vertical angles. So every pair of intersecting lines should create two sets of vertical angles. So then our next one is a linear pair. And so a linear pair, now we're going back to it has to be two adjacent angles, which means they have to have that common side and vertex, whose non-common sides are on the same line. So what we end up seeing often is something that looks like this. So we have angle A, which is going to be this green angle here. We're then going to call this angle B, which is going to be this red angle here. So notice they are adjacent. They have this common side here. They have this red and green side. They have a common vertex. And then the other two sides, these sides, are all on a straight line. So I think of linear pairs as making a line. That is what our linear pairs do. There are two angles, and only two angles. They have to be adjacent, so they have to have this common side and common vertex to make a straight line. All right, so let's take a look at our first example. We need to determine whether the labeled angles are vertical angles, linear pair, or neither. So when we look at angle 1 and 2, well, here's angle 1, here's angle 2. To me, it looks like they have this side. So we know that they're adjacent angles because they have a common vertex and a common side. And so here they make a straight line. So we would say angle 1 and angle 2 are a linear pair because they are adjacent and their non-common sides make that straight line. We look at angle 3 and angle 4. Well, dude, we've got a whole bunch of intersecting lines. Okay, but what happens here is we're going to say that they are neither. Vertical angles have to be created by intersecting lines. This is a line that has two rays coming off of it. Okay, the blue and green are two different rays. They don't make a straight line. So angle 3 and angle 4 are what we call neither. And if we look at angle 5 and angle 6, we've got two intersecting lines. We've got green and blue. And then we have angle 5 and angle 6. Well, they're not adjacent because they're not side by side. And they're created with these two V's. They're two distinct V's. So these are what we call our vertical angles. My picture was too big to fit in there. Hopefully you guys can fit vertical angles in there. But they are non-adjacent, and their sides are made up of these intersecting lines. All right, if we take a look at postulate 7, we're going to take a look at what a linear pair means. So pause this real quick. Okay? Just a little bit of type-1 here. All right, sorry guys. So what postulate 7 says is the linear pair postulate. Remember, these are things that we just considered to be true. So if two angles form a linear pair, then they are considered supplementary. We've got that supplementary, we have that straight line. And that's what we said about supplements yesterday. So if we look at this, symbolically, what this postulate means is that the measure of angle 1 plus the measure of angle 2, when we think of this being a straight line, is going to equal 180 degrees. So if we see two adjacent angles, and we know that the sum of their measure is 180, we know that they are supplements. So that's our postulate that we're going to rely on. Now we're going to take a look at the vertical angle theorem. So once again, these are things that we are going to be able to prove as being true. So what we know is that vertical angles are congruent. So when I look at my vertical angles, I've got angle 1 and angle 3 that are opposite each other. So angle 1 is congruent. The measure is equal to angle 3. The second pair we have is angle 2 and angle 4. So I know angle 2 is congruent, is going to be equal to angle 4. So each pair of intersecting lines is going to create two pairs of vertical angles, and those vertical angles are going to be congruent. So now what we're going to do is we're going to take that theorem and we're going to use it for some solving. So we need to look at the linear pair postulate and use that. So we want to find the measure of angle RSU. So we're going to take and trace RSU. I'm finding this angle here. All right. I know that angle RSU and angle UST are a linear pair. By the linear pair postulate, I know that they are supplements. And so what that means is that angle RSU, the angle we're looking for, is going to be 180. It's going to be this straight line minus the 62 that we already have there. So we're going to take 180 minus 62, and I think your book writes it out in a straight line. So we'll put it over here, minus 62 degrees. And so that's going to give you an answer of 118 degrees. All right, so it's kind of what we've been doing before, but we're going to expect you to recognize that this is 180 degrees, and we won't be telling you. All right, now we want to use the vertical angle theorem. We want to find the measure of angle CED. So once again, trace CED. So we're finding this angle right here. We know that angle AEB, the 50-degree angle that they give me, and angle CED are vertical angles. And so by the vertical angles theorem, we know that those two angles, angle AEB and angle AEB, is congruent to angle CED. All right, they use the congruent symbol there, sorry guys. But angle AEB is congruent to angle CED. So I know the measure of angle CED equals the measure of angle AEB. And so when this is 50 degrees, I know that both of them are going to be 50 degrees. So the measure of angle CED is 50 degrees. All right, we got a few examples here before we start to get some follow-ups and checkpoints. So now what they want us to be able to do, ladies and gentlemen, is take a diagram, take two intersecting lines, and find the measure of all the angles. Because what happens is two lines intersect, they create a linear pair, and they create vertical angles. So we have all of these together. So let's see if we can put this on the screen. All right, so I'm trying to find the measure of angle 1. I want to find the measure of angle 2, and I want to find the measure of angle 3. So here's what I know. I know that angle 2 equals the measure of 35 degrees. it's equal to this angle right here. These two have the same measurement. So 35, the vertical angle to it is angle 2, so it's 35. I know angle 1 and angle 2 make a linear pair. They make a straight line. So I'm going to take 180, subtract the 35 degrees that I now know for angle 2, and I'm going to get 145 degrees. So now I can replace this big arc with 145 degrees. Well, just like we had vertical angles for 35 and 2, I know 1 and 3 have equal measures because they are vertical angles. That's our vertical angle theorem. So the measure of angle 1 and the measure of angle 3 are both equal to 145 degrees. So the way I would like to see your answers are measure of angle 1, the measure of angle 2, the measure of angle 3, instead of just trying to draw things on a diagram. So we put in our 145 degrees for angle 1 and angle 3, and then we would put in our 35 degrees for angle 2. All right, now what we're going to do is use our algebra. Yay! We get to use algebra. So I'm trying to find the value of y. This should be a subtraction. For some reason the minus isn't showing up here in my video guide. Sorry for that. So what we know is that we know these are two vertical angles. I need to be able to look at this, outline these, see that they are not adjacent. But I know 4y minus 42 degrees is equal to 2y degrees. Because I have just 2y over here, I am going to subtract the 4y from each side. And so when we simplify each of those sides, we are left with a negative 42 is equal to a negative 2y. I have to divide each side by negative 2 to finish off my algebra. And so I get y is equal to 21. They're not asking me to find an angle measurement yet. They just want me to find y. But your follow-up, what we're going to check in class, is check your answer for example 5. So you're going to take your answer for y and plug it into your original equation. So you had 4y minus 42 is equal to 2y. And what you want to check is y equal to 21. So we will check in class. So I'm expecting you to come on Thursday with this follow-up done so we can look at your algebra, and I will randomly call a name off to bring that up to the front of the room. So you know your algebra, you know how to check solutions. We did this with segment bisectors. You can do this here today. All right, here's our checkpoints. We're now taking a look at applying all of this. So I highly recommend you pause the movie right now, do 1 through 6, and then push play and finish up to hear my answers. But if we take a look, we have to find all 3 angles. So I'm going to take a look at angle 1, the measure of angle 2, and the measure of angle 3. Angle 1 is forming this linear pair with angle 28. So I need to do 180 minus 28 degrees. And that 180 minus 28 is going to give me 152 degrees. Now you can jump around, solve in any order. But once I know that this is 152 degrees, I'm going to check my vertical angle, which is angle 3, and that's also going to be 152 degrees. We could have started with angle 2 right away, because angle 2 is a vertical angle to the 28 degrees that's there, and we know our vertical angles are congruent, so we have the measure of angle 2 being equal to 28 degrees. So we're kind of doing the same thing, it's just the application of vertical angles and their relationships, and then our linear pairs. 124 is a vertical angle with angle 2, so I know angle 2 is 124 degrees. And I know that now 124 makes a linear pair with angle 1. So I need to take 180 minus 124, and that's going to give me 56 degrees for that. So angle 1 is 56, and then my vertical angle there is angle 3. So the measure of angle 3 is 56 degrees. We take a look at the third one. Measure of angle 1, measure of angle 2 is what I'm looking for, measure of angle 3. Angle 2 is opposite, or is vertical, to the 67-degree angle. So angle 2 is 67 degrees. We could look at this way as angle 3 is also a linear pair with the 67. So because they make a straight line, we do 180 minus 67, and we should get 113 degrees there. If angle 3 is 113 degrees for that, then I know angle 1, its vertical angle, is also 113 degrees. If we take a look at the algebra we can do, we need to be careful where they're putting things. Here we have vertical angles. So we know our vertical angles are equal. So I have 3x is equal to 2x plus 10. So you really want to draw and see, am I making these when I outline my two angles, or am I making a straight line with those? And so I'm going to, when I make the V, when I make my vertical angles, I'm going to set them equal to each other and then solve for x. So x is equal to 10. When we look here and outline these, we outline our two angles, and they are vertical. There were no common sides. So I've got 4 different sections highlighted. So I know that they are vertical, and so I know they are equal. So I'm going to set them equal to each other. I'm going to solve. I subtract 3 to isolate the variable, and then I divide by 2. And so r is equal to 43. Now this last one looks a little bit different. If I outline my two angles, I don't end up making two V's. What I end up making here is this straight line. And so that means what we understand from our linear pair postulate is that those two angles are supplements. So when you make your straight line, if you make a straight line, you have to add and set them equal to 180. So I have to take my two angles, add them together, and set them equal to 180. So I'm going to have 35t plus 5 is equal to 180. This time my variables are on the same side, so I can combine those together. I minus 5 from each side, and I get 35t is equal to 175. We go through and divide by 35. You may need to pull out your calculator, but we get t is equal to 5. So hopefully you guys did well on those problems on your own. We will go over any questions that you still have in class on Thursday.